Calculate the slope of a line that passes through the points 6, -8, and 3, -4. Each of these points has a y value. I'll underline that in orange. And each point also has an x value, and I'll underline that in green. We know that the slope of any line, right, slope, is always equal to the change in the y values, and we divide that by the change in the x values. And if I look at this, it really doesn't matter the order I do this as long as I'm consistent. If I look at my y values, for example, I could say -8 minus a -4. So I could put -8 and then minus -4. So that's how y changed. And then I can go 6 minus 3 for the denominator. When I look at this, my numerator is -8 minus -4, which is -8 plus 4. So I'm left with a -4 in the numerator, and my denominator, 6 minus 3, is 3. So I know the slope, right? The slope of the line is -4/3. In A, they asked me to write the equation of the line. And as happy as I am that I know the slope, it's not enough. I also need to know the y-intercept. And it doesn't matter which of the 2 points I choose, I can use either one of them to find the y-intercept. And I'm going to go ahead and use this first point. For that first point, you can see that I have an x value that's equal to 6. And you can also see that we have a y value that's equal -8. And we have a slope, the variable we use for that is m, is still -4/3. So if I consider a generic linear equation, y equals the slope times an x value plus the y-intercept, I know 3 of those variables, right? I know x, y, and m. What I don't know is b, the value of the y-intercept, and that's what I need to come up with to write the generic equation of this line. So I'm going to go ahead and plug in the value of y that I have. We know that y was -8. We know that our slope is -4/3. And we also know that the x value we have is 6. And of course we've got plus b, this y-intercept that we're trying to find. On the left-hand side, or right-hand side rather, when I multiply -4 times 6, that gives me a -24. And -24 divided by 3 is -8. So this equation becomes -8 equals -8 plus b. Again, 6 times 4 is 24, -24, and -24 divided by 3 is -8. If I add 8 to both sides of this, this gives me the following, which means that b, my y-intercept, is at the point 0, 0. It's going right through the origin. Now that I know the slope of this line and the y-intercept, I can write the equation of the line. And that's question A. And the equation of this line, because it has a y-intercept of 0, is just simply y equals -4/3 times x. And then the final question asks us to decide whether or not this point, -3, 4, is on that line. So I'm looking to see, is -3, 4 on this line? Is this point on the line from part A? Now, it will be on the line if that point satisfies the equation, makes it true, and it will not be on the line if it doesn't satisfy it. So let's go ahead and take the x value. This point has an x value and it has a y value, and we're going to plug both of those in and see if it makes this true. So for example, the equation that I have was y equals -4/3 x, and I'm going to replace y with 4 from my point. And my question is that the same thing as, on the other side I've got a -4/3, and I'm going to multiply that by x, which is the number -3. So if I multiply -4 times -3, oops, that gives me, sorry about that, that gives me a, let's see, -4 times -3 is +12, and 12 divided by 3 is 4. So this actually becomes +12 over 3, which is 4. So and I have a 4 on the other side. So I would absolutely say yes, because this point -3, 4 made this true. I got the same value on both the left and the right hand side. They both became the number 4. I can say that yes, the point -3, 4 is on the line. So that's my answer to B. The point -3, 4 is on the line.